Hey guys, so today we're going to be talking about what a natural log is. And so in order to talk about a natural log, we need to talk about E. So E is a mathematical constant. So E is not a variable. It is a constant, so it has some value to it. It's 2.17. I could be way off. 8. I think I am. Hold on. And I was incorrect. It's 2.718. So I had the digits right. Okay, so 2.718, blah, 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 and it goes on forever, kind of like pi. So it is a constant that has some value. It's not a variable. So you can think of it like pi. So E often occurs as the base of an exponential and logarithmic functions, and those are going to be more like our real world scenarios with these natural logs. So the exponential functions with base E are called natural exponential functions. I don't know why there's a second blank there. And then an example of an exponential function with base E would be like y equals e to the x. And the logarithmic functions with base E are called natural log functions. And so an example of this would be y equals ln of x. And then we won't talk about the abbreviation. So ln of x is the go-to, and then y equals e to the power of x is our go-to. So whenever we're converting between forms, between our exponential with a base of e and our natural log, it's going to work the same way as our plain logs. So we've got our base here. So natural log, we don't have to say base e, but let's do it just for this first one, because that would be first, middle is 24, equals x. So anytime you see ln, you would assume that the base is e, so ln 24 equals x. So kind of like whenever you see log x, you assume that the base is 10. Whenever you see ln x, you assume that the base is e. Now number 2, the same thing. So e is our base. And so we've got natural log of x equals 9. Now on the second part here, we're going to be rewriting it in exponential form. So the first would be the base of e. So you have e to the power of 58 is equal to x. And then we've got e to the power of x is equal to 6. So just be careful converting from the log to the exponential, that we know that the base is e. We have to have that base of e. But you won't see it written there. So anytime you see ln, you know that the base is going to be e. Now on this next part, we're condensing them and expanding them the exact same way that we have those properties with the other logs that we work with. So whenever we have this plus, we'll take ln 3 times 16, which would be ln 48. Now number 8, we've got minus 2 times, so this 2 becomes the power, and that minus means we've got division. So this is the natural log of 63 over 3 squared. And 63 divided by 9 is 7. So this would be the natural log of 7. Now when we're expanding, we have to be able to pull these apart. So right here, there's multiplication. So whenever there's multiplication, we know that they are adding those two separate logs. So log of 5, natural log of 5 plus the natural log of x. And on number 11, we're going to take this power, bring it to the front. So 2 ln, and we've got division, so we're going to have subtraction. And then this needs to go to the front as well, so we have 6 ln of a minus 2 ln of b. Now the next part will be solving these equations. So whenever we're solving equations using natural logs, we know that the base is e. Once I have that the bases are the same and they equal each other, then that means this has to be the same. So I'm going to take 4x minus 27 equal to 15 minus 2x and solve for x. So I'll add 2x to both sides. I get 6x minus 27 equals 15. Add 27. 6x equals 42. Divide by 6. And x equals 7. Now when it says check for extraneous solutions, we have to plug that back in. Let's say ln of 4 times 7 minus 27 equals ln of 15 minus 2 times 7. So ln of 28 minus 27 equals ln 15 minus 14, which is natural log of 1 equals natural log of 1. So x equals 7 is not extraneous. Now number 15, we've got these 2 logs on the left, 2 logs on the right. So what I'm going to do is condense the left side, condense the right side, so that way I have 2 logs that equal each other. So this is ln, we've got minus, so 72 over 4 equals ln 6 times a minus 2. 72 divided by 4, 18. So that's ln of 18 equals ln of 6a minus 12. And now we have natural log equals natural log, so we'll set those equal to each other. 18 equals 6a minus 12. Add 12. 30 equals 6a. Divide by 6. And 5 equals a. So now we have to plug it in, make sure that it works. ln 72 minus ln 4 equals ln 6 plus ln 5 minus 2. ln 72, let's condense that again. So that's ln 18 equals ln 6 plus ln 3. ln 18 equals ln 6 times 3. Ln 18 equals ln 18. So 5 equals a, or a equals 5. It does work, it's not extraneous. Number 17, we've got the natural log of 8x equals 2. Now we don't have logs on both sides, so what we can do here is convert our first, our last, our middle. And I know my base is e, that's the first. And so I have e squared equals 8x. Remember, e is a number. So I'm going to then divide out by 8. So x equals e squared over 8. Now I'm going to find out what that is, and it's approximately 0.9236. So that's approximately what x is, that e squared divided by 8. And then I'll plug that in to make sure that it works. I'll say ln of 8 times e squared over 8 equals 2. 8 over that 8 would just cancel out, so I have ln of e squared equals 2, and if we check that in the calculator, it is a true statement. So this does work as what what x would equal. We're going to do the same thing on 19. We're already in exponential form. So e to some power equals 57. So ln of 57 equals x. We can find what ln of 57 is in our calculator, and it's 4.0431. We say that's approximately what x equals, and then we can check. Does that work? So e to that power. And whenever you're checking in your calculator, you're going to want to use the full decimal, not just not truncating it. So you would want to store it as your x and then take e to the power of x. And if you don't know how to do that, I'm happy to pull up the calculator on a Zoom. I don't have the calculator software on this tablet, but I'm happy to pull it up on a Zoom and show you guys how to store your variables, so that way you can use them with the entire decimal and not just truncating them. Now in 21, we've got 5e to the 4n equals 95. So what I can do here is get that e isolated as much as I can and divide by that coefficient of 5 on both sides. And I get e to the power of 4n is equal to 19. And now remember, we want to solve for n, but n is inside that exponent, so I'm going to convert. I get the natural log of 19 is equal to 4n, and I want to get n by itself, so I'll divide by 4. I get that the natural log of 19 divided by 4 is equal to n. So now I'm going to put this into my calculator and see what it approximately is. So I get 0.7361, and then we'll check by plugging that back in. So again, I'm going to store that as my variable and take 5e to the power of 4 times that variable and see if I get 95. And I do. So I'm going to say that I checked that in the calculator and it worked. So n is approximately this value. So again, I'm happy to show you guys how to store variables if you don't know how. I might just make a quick video on how to do that so we can check on whether or not our answers work. Oh, we've got one more. On 22, we've got quite the doozy here. So on 22, the first thing we want, like the last one we just did, is to get E as much alone as we can. So we want to isolate it as much as we can. So I'm going to subtract 3, and I get 2 e to the power of c minus 9 equal to 84. I'm going to divide everything by 2, and I get e to the power of c minus 9 is equal to 84 divided by 2, which is 42. And now e is as much isolated as it can be, so then I'm going to convert natural log of 42 equals c minus 9. And I want c by itself, so I'm going to add 9. So natural log of 42 plus 9 is what c is. And then we'll find that approximate value in our calculator. ln 42 plus 9. We get c is approximately 12.7377. Then we'll check in the calculator by storing that as a variable. So I'm storing it as x on mine. We'll have 2 e to the power of x minus 9 or c minus 9, then plus 3. We want to make sure that equals 87. And it does. So then c is that approximate value. So that is all for today. And then tomorrow we'll be solving using our logs. So we've already started solving with these natural logs, but tomorrow we're going to solve with our regular logs. So we'll get some more practice there. Make sure that you turn in all the ones highlighted in yellow, and then I'll see you guys tomorrow.